This is Cybersound, your simplified and fundamentals-focused source for all things cybersecurity, with your hosts, Jason Pufall, Stephen Maresca, and Matt Fusaro.
Welcome to Cybersound. I'm your host, Jason Pufall, joined, as always, by Matt Fusaro and Steve Maresca. Hey, guys.
Hey there.
Hey. So today we're going to discuss the security challenges. I guess challenges is a good word, right? But security challenges for sort of IT and OT, operational technology devices. So maybe first thing is, what is OT? Either of you want to take a stab at? I don't think it's super complicated, but either you want to take a stab at OT?
Sure. I mean, it's a general category. It's more of a newer term for stuff that's existed for a long time, just so we're clear. But stuff that tends to be included would be industrial controls, temperature sensors, valves, programmable logic controllers, things that have chained logic but aren't necessarily programmed in a way that, higher level languages would be used. These are things that deal with manufacturing, movement of goods and materials across an assembly line, things of that sort, sequencing, metering, measurement types of devices.
So I'm going to go out on a limb. IT stuff, servers, desktops, network switches, things like that. Easier to maintain probably, right? A lot more publicly available patches from vendors, maybe just generally broader support. So what makes OT more difficult?
Well, there are actually two answers to that, and both of them are conflicting. They're easier to maintain on one level because the protocols that are used, the wires that are used, they're built for robustness. They work in environments that are high vibration, high temperature, acidic, things of that sort. These are designed to last, which
IT.
is OT.
Right. Okay, let's be specific.
Right.
And usually only have a couple functions.
Right. Maybe they actually do all of their communication over literally one wire.
So is longevity akin to maintenance? Because that sounds what you're talking about is something that can last a long time ignored.
Yeah, it reduces maintenance requirements. From a typical IT context, what that means is that you have material that was put into place with technology that may not be changed for 10 years. That could be a risk, therefore a maintenance headache. It depends on the context here. Some people would see it as a maintenance boon to not need to touch it for a long time. Others would consider it a maintenance headache because of the fact that it's not received a patch.
Or the manufacturer of that device just isn't around anymore.
Right.
And that's
super
certainly
common.
likely.
Right.
Yeah. AT&T is probably one of your best examples. Large phone companies, they've got technology from the 80s still running right now.
Right, routing calls and just hoping it works.
Yeah, routing calls, testing data circuits, that stuff is ancient.
So then where are our challenges? If you get longevity out of a lot of the stuff. And frankly, you can't say the same out of a lot of your more mainstream IT infrastructure, right? So you get longevity, but because there's maybe reduced or more challenging patching or perhaps in some cases no updates available at all, you probably introduce a fair amount of security risks, maybe just security concerns to stuff like this as other technologies have evolved.
Yeah, a lot of the risk that comes into especially OT is what these OT systems are being hooked up into, right? So to gain efficiencies, to automate how they're actually used, they're hooked up to actual server farms in some cases, or small devices that are on site that may actually be using a web server to take calls from an application somewhere, so that you can centralize your HVAC team. So you could centralize anyone controlling valves for anything like that. There's so many examples out there.
Right, but other examples would be like sensors on a pipeline,
right,
literally in the middle of nowhere, hundreds of miles away from a tech.
Yep.
That happens to connect over the cell network or something to that effect. There are lots of situations of that sort that are challenges. Maintenance for a lot of operational technology is actually replacement. Right. It broke. You're going to swap it out with another part. It's never actually being updated per se. It's being swapped.
Right, with something that you hoarded that you found
Right.
previously, or it's something new?
Pretty common.
Yeah.
Yeah, pretty common. It's an old part.
So is there anything different in protecting these, though, than you might with your more standard IT infrastructure, right?
Well, a lot of times. So, for example, in IT infrastructure, we'll do active scanning against them, right? To find, hey, does it need updates? Is it vulnerable to any of these types of protocols or attacks that we know about? If you do that with some OT, you can end up actually causing a problem, right? You don't necessarily want to be actively probing some of these things and turn on a gas pipe, for example, that shouldn't be turned on. So how do you do these things now, right? How do you check for threats? How do you identify traffic that should be or shouldn't be going in and out of the networks that they're connected to? It becomes more of a challenge because you have to have somewhat of a hands-off approach to it. Otherwise, you are going to start interacting with physical things in the world, right?
Yeah, but a lot of risk management and risk discovery in IT involves probing live equipment. In OT, the safest way is in a lab, in isolation, in controlled conditions, something to that effect. A lot of these devices they have such low computational power that merely interacting with them distracts them from their very real-time oriented task that they're obligated to perform, and therefore you've created a problem because they don't function. So very different types of strategies attached to how you maintain them and assess them.
How much of this conversation are we talking about 20-year-old devices versus maybe something that performs that same kind of function, right? Controlling the HVAC systems, for example, but something that's been installed in the last year. I mean, there's a certain set of regulatory requirements that sort of define how these things are designed now. I believe to some degree what their sort of vendor maintenance requirements might be and things like that. So, has OT gotten easier to protect as in more recent times, or not necessarily?
I think it's gotten easier to protect. There's more tools out there. There's more detection technology. I think more organizations are starting to understand that they can't just connect these things into their corporate network without any thought behind it. But there are still organizations out there that don't think about it. But yeah, a lot of the things that we talk about, really fundamentals are where you need to be when it comes to OT, right? Segmenting your networks so that you're not on the same vulnerable networks as your corporate devices. Making sure if they do have software that they're actually patched, and doing some type of monitoring, right? Just having some visibility into what it is that's out there. How do you get to it? And what do you do if it is compromised? What's the risk there?
A lot of what we would normally think of as re-architecting is a planning exercise for OT, pre-deployment. Air gap is a term adjacent to network segmentation that Matt just mentioned in anything that's OT specific, because you expect to have a discrete severance of any sort of connectivity between the rest of your environment and OT. It's a deliberate choice. Therefore, if you build it out of the gates being correct, it tends to be secure, tends to stay secure, even if it suffers from some future vulnerability.
Right. I think a lot of this started being an issue when you started seeing things like smart grid come up, right? That's one of the big worries about a lot of electrical infrastructure, water infrastructure, the utilities coming into a more connected world now. They at first had issues because they were not segmenting those things off, right? And yeah, I mean, you end up with problems because of what you're trying to get automation and get efficiency out of something, which is going to require you connecting these things together. And now you've created a point of entry.
So, example of that, 2 examples. Far more domestic, if it's a switch, an electric switch that's connected to a socket just to turn on and off a light, you can maliciously flip that on and off so many times that you cause the relay inside to fail and maybe short out. You've destroyed something, at worst caused a fire if there's some protection lacking in the device. Then the other example is something more, let's call it real-world espionage-oriented with Stuxnet, which was Microsoft Windows worm that propagated across networks that happened to have industrial controls accessible from them. It was a SCADA vulnerability that targeted Siemens controllers. I mean, that we don't go into that here, but it's exactly the same sort of thing. It was used to destroy attached industrial systems.
Certainly, it seems like most companies probably have a good handle on their information technology resources. They may have an inventory, or at least they have a passable understanding of what's on their network. I suspect a lot of organizations don't really even fully understand what they might have in their environment for OT devices, right? Either the vendors directly providing services, so they've got something hooked up there, or right, it could be in place for 20 years and have had multiple IT teams even sort of pass through an organization and not know it's there. So I think inventorying is probably a key initial thing, so you know what you have and you know kind of where your risks are. Because you brought up, Matt, this is really a risk exercise as much as anything, because there may or may not be, patches or some specific technical controls or compensating controls you can put in place, but you really need to know where your risks are and make some decisions around that.
Yeah, I mean, a good example is we would walk into, back when I did a lot of project deployment for IT departments, we would walk onto a shop floor and they would have tons of CNC machines. And they were all just connected to the same network as the rest of the computers, because they had engineers that were sitting, designing things, sending them to those machines. If that place got compromised, you now have access to all of that, right? So if you want to break those machines, if you want maybe even introduce a small flaw in a part, right? It would be very difficult to detect those things because they had all these things on the floor. They had no idea how it was connected, right? So the minute we leave, they have a huge problem if someone were to compromise that network.
Yeah, and we're talking about all this as if it's, say, security vulnerabilities, but it makes me think of a story in the past where there was a unit attached to a phone switch, essentially, that simply collected call records, and those call records were utilized for billing purposes. So when it broke, people cared because they couldn't bill their customers, but there was only one person in the company that understood that call record collector even existed, and that one person had to build a custom cable to be able to connect to it because there was only one way to actually get any visibility. So you literally had this, pretty critical old call box collector that only one person could support, and that person needed to make sure they had their uniquely crafted cable to be able to do it. Like, these aren't straightforward things necessarily to interact with always, but it's not always some major security risk necessarily, right? It just there's a whole variety of things these days control.
Yeah, it's operational risk as much as anything else, absolutely. And there are lots of surprises beyond the maintenance and accessibility with our laptops, which no longer have serial ports.
Yeah, there's that too.
Some sensors, like temperature sensors, are way more capable than they need to be. We've seen them running mail servers. Like, that makes no possible reasonable sense, but they exist.
Solar charge controllers were, those are notorious for having a bunch of services on them. We found one in an incident once that was being contacted by some questionable IPs.
Yeah, so not a lot of care building them necessarily. They get them to perform the function they need. It might be a lower end piece of just traditional computing technology that they repurpose for something else.
Absolutely.
Yeah. So in many ways, I feel like we've sort of said in this episode things that we've said in the past around, take care of those fundamentals, collect an inventory, think about the infrastructure in terms of risk, and be judicious about the way that you actually protect it. And then, for those things that you can, network segmentation and monitoring, make sure you put those things in place. But I don't know that we've identified anything incredibly unique about these, other than they may be old and perhaps a little bit more difficult to maintain. As always, if anybody has any questions about operational technology, feel free to let us know. We're happy to talk. It's not easy sometimes even to get the inventory that you might need. You might not be familiar with it, but there's a variety of tricks and tips that we can provide you to make that job easier. So we're happy to chat. And as always, we hope you got value out of the podcast, and thanks for listening.
We'd love to hear your feedback. Feel free to get in touch at Vancord on LinkedIn or on Twitter at Vancord Security. And remember, stay vigilant, stay resilient. This has been Cybersound.